Welcome to the third episode of the 𝐾𝐸 36 wiring videos. I'm still waiting for my batteries, so I've decided to push on with some other parts. So in this episode we'll take a look at Victron's Smart Shunt. So let's see what we got here. This arrived in the post today. I know what it is. It's the Victron Smart Shunt. This is the 500 amp version, as long as they've sent me the right thing. So let's take a look. The reason I've ordered the Smart Shunt is because I want to know how much power goes into the battery and how much power goes out of the battery, and I also want to be able to capture that in a log, and that's something I can do with the Victron setup. I'm sure that the Seplos battery and the BMS will give me the same figures. I might not be able to log it, but the reason I have this one is because I also want a redundancy reading, or an extra reading, so I can read the readings from the Seplos battery as well as the readings from this Smart Shunt. And if they are different, that might indicate that there is a problem, and if they're not, then that sounds like everything should be okay. So I've got a little Victron Energy kind of warning note here. We can have a quick look at that. See what it's saying. So that is the wiring diagram. You have all the different connection and terminal types, which is great, and all the different connection points. It's a little piece of a thing here. Okay, so that must be to register the actual hardware, because I think it comes with a warranty. I think the warranty is different depending on if you connect it to a lead battery or if you connect it to a lithium-ion battery. So here we also have a quick installation guide, so that will come in handy at some point. We'll put that aside. And here we have the actual shunt itself. I went for the IP65 version, which is the version that should take a little bit of water if you accidentally would spill water on it, because it's covered in some form of I guess epoxy liquid, so it is safe from that point. So IP65. They have a non-IP65 version as well, where the cables aren't attached directly to the shunt, but you have them with little plugs. I just thought this one felt a bit safer. What I probably will do as well is build a little nice enclosure for this one, just in case, because I guess that you don't want to accidentally touch these two points, because you will have a short. So it looks very sturdy. This is metal. This is most likely copper or brass, and it says 500 amp, so that should be the one. So perfect. So all I need now is the batteries, so I can connect it to the battery box and see what goes in and what comes out. So these two are M10 bolts, so I'm just going to make a note of that so that I can order some lugs. So a quick one on the reason why I've gone for 500 amps. According to my calculations, I shouldn't draw more than 415 amps. And when you choose your smart shunt, you want to make sure that you look at your draw and not your battery capacity. So it's the draw that's the important bit. So if you stay above what you think you will draw, you should be okay. So it has nothing to do with how much amp you have in your actual battery. Another handy thing is that it comes with Bluetooth, which means that I can read all the readings on a dedicated app that Victron supplies. So you download it and you connect it to this Smart Shunt, and you can then look at all the values on the phone, which is very handy. I have started to design the aluminium outer box for the batteries. I'm doing that in 𝐾CAD at the moment. I just have some more design to do before I can send it up for laser cutting. I'm also currently making some larger plastic 3D printed feet for the box that I'm going to put a little bit of rubber in so that I have a bit of flexibility. And the main idea is that I want to make sure that I don't have a connection between this steel foot and the aluminium box. So there will be a thicker layer of plastic here at the bottom, and a little bit wider as well for more support. Not sure if you can see it properly, but I am making 2 rubber inlays for the big puck and a smaller inlay for the little one that will sit between the head of the bolt and the actual surface itself. Okay, so we now have an inside little part with a rubber seal on it that goes in here. And then we have on the top of that a puck with the 2mm of rubber seal on the inside as well. So we now, when I push this into its position where it's going to be a bit tight, that rubber will flex and we should have a closure of this gap here. We definitely should have enough material between the steel and the aluminium to make sure there's no corrosion, and also I have a little bit more surface area to rest these batteries on. Another reason for these feet is also that I am going to slide the battery into its position, and these feet should make it easier for it to slide before I lock it into its position, because it's going to be nearly 120 kilos and I'll have to kind of push it by hand, so that should help. So now I just need to make another 8 of these in white ABS plastic instead, and we should be good. I have added the Smart Shunt as number 4 on the illustration of all the parts, so the master illustration. Thank you for watching to the end on this third episode. As usual, if you have any questions or concerns, please stick them in the comments and I will respond within 24 hours. If you're interested in the boat building itself, then there's a different playlist for that. And if you are interested in the build of a boat motor that I'm building, then you find that playlist up here somewhere. Anyways, thank you so much for watching and I'll see you next time.